Alrighty, chemistry students, today we are going to focus on how we're going to use all this information we've been learning about naming and convert it into actually writing chemical formulas. Okay, so a chemical formula is just an organization of things that shows what's going in and what is coming out of a chemical reaction. So remember, we have both ionic compounds and covalent compounds, and we have those different rules for naming both. So if you need to review those, make sure you go back and review those rules for naming those. Remember, the rules for ionic compounds is we're looking at charges and we need to swap those charges. Whereas with covalent compounds or molecular compounds, remember those words mean the same. We are only looking at the number of atoms in each element. And we're going to need our prefixes mono, di, and tri to name those compounds. So let's just jump right in and do some practice problems. So we might have something like sodium oxide in water gives us sodium hydroxide. So we're going to have to think back a little bit to first semester. And in first semester, we talked about reactants and products. Do you remember what those terms mean? Remember that reactants are what are going into an equation and products are what are coming out. So in this specific example, we are putting sodium oxide in and water in. So these are considered our reactants. I'm not going to spell that whole thing out. While sodium hydroxide is coming out. So sodium hydroxide is our product. Notice this little arrow here. That means yields. That's giving us our product. So what we're going to be doing is just practicing converting all of these names into a formula-based chemical reaction. So I do have a little whiteboard here that we are going to use. So let me go ahead and copy this onto that whiteboard. Alrighty, so again we have sodium oxide in water gives us sodium hydroxide. I don't know why this isn't going away. There we go. So sodium oxide. We know with sodium oxide we have sodium, which is Na, and we have oxygen, which is O. Remember that when we're going from a compound to a name, we have to take a couple things into consideration. So our first step is always to decide, is it ionic or covalent? And in this situation, it is an ionic compound, so we're going to follow our rules of naming ionic compounds, which we're going to need our oxidation numbers. Our oxidation number for sodium is +1, which we get off our periodic table, and our oxidation number for oxide, or oxygen, is -2. So we're going to take these charges and swap them so that we have Na2O. Okay, Na2O plus water. I think you all know what water is. It's H2O. So Na2O plus H2O water yields our arrow. Again, this arrow means yields sodium hydroxide. So we again know what sodium is, but hydroxide is kind of a funky word, and notice it ends in "ide" still, but it's not a general element. Hydroxide is going to be one of those special polyatomic ions. So we're still using sodium, Na, and hydroxide, maybe you remember, is OH. If not, make sure you have that polyatomic ion sheet out in front of you. It is under our important documents in our Canvas page. Na is still going to have that charge of +1. And our OH has a charge of -1. Let's get rid of that. We're going to swap those charges again, so it's Na1, OH1, which we can ignore those ones. So we have NaOH as our answer. So the formula, sodium oxide plus water yields sodium hydroxide, is the same as Na2O plus H2O yields NaOH. And remember, we're putting that OH in parentheses because we're always putting our polyatomic ions in parentheses. So that's our first one. Let's try out another. Alrighty, so here we have the opposite. We're starting with a formula and we're going to write out the names of all the compounds. So we have BaCl2 and then we have a little AQ in parentheses plus Na2CrO4 parentheses AQ yields BaCrO4S plus 2NaCl aqueous. So let's first see what these little things mean. So in your notes, as well as on the slide here, I have this big chart. So we know that a plus means. We know that a plus means we're adding two things together. It's used to separate two different compounds. We already talked about the arrow meaning yield, so it's used to separate the reactants from the products. Remember, the reactants are what are going in and products are coming out. This is something we haven't seen yet, but this is just a double yield sign that shows the reaction can go both forwards and backwards. It doesn't just go one way. G means it's in the gaseous state, so that compound normally occurs as a gas. S means it occurs as a solid, and aqueous means it's occurring as an aqueous state. Aqueous means liquid in a way, but basically what it means is it's dissolved in water, so that compound is dissolved in water, making it liquid. So let's use that terminology to see what's going on here. So I'll type out this one. So we have BaCl2. BaCl2 is again an ionic compound, so we're just going to name the first element of barium, and then we have chlorine. Okay, chlorine, but we have to change the ending to chloride. So we have chloride. So we could say aqueous barium chloride, combines with. Okay, so this combines with term means adds to, combines with Na2CrO4. We know that Na2 is sodium, and CrO4 is one of those things on our pink sheet. So make sure you grab out, or yours online isn't actually pink. It's just your polyatomic ion sheet. So make sure you grab out your polyatomic ion sheet. And here's one I just found really quick on Google. So this polyatomic ion sheet, again, we're looking for CrO4. So if we can zoom in a little, I don't know if it'll let me zoom in. I think I can make it bigger though. Oh my goodness, there we go. CrO4 is found right here, and you can see that that's chromate. So CrO4 is chromate. Go back to this page. Things are not going well today, kids. Now we have a rainbow. Here we go. Sodium chromate. Here we go. With sodium chromate. Yields. So aqueous barium chloride combines with aqueous, we can go back in and add those words, sodium chromate to produce, or to yield, to form, to give off. Again, remember that we don't need to include those Roman numerals here because sodium is one of our compounds that is in a general column and is not a transistor metal. So to produce barium chromate and sodium chloride. I have forgotten two things in this answer. Have you noticed what they are? Hopefully you picked up on that I need to say that they produce solid barium chromate and aqueous sodium chloride. Okay, so again, make sure you're including what the plus and minus mean, or plus and yield sign mean. Include the aqueous signs, include the solid signs, include all of that. Let's try one more out together. So this one again is a little bit different. This time we're given solid calcium reacts with solid sulfur to produce solid calcium sulfide. So we're kind of starting with what we were making up here. So solid calcium, Ca, solid calcium, and reacts with solid sulfur, S, to produce calcium sulfide. So we can just do a general overview of what we think this might look like, and then we can go back in and add things to it. So if we have solid calcium in the solid form, that's just going to look like Ca, and it's going to have a little S next to it because it's solid calcium. When we have solid sulfur, again, we're just going to have that little S. That word produce told me that I'm going to be making something, so that's when I have my yield sign, to produce calcium sulfide. We can do a little work up here with calcium. We know that calcium has a +2 charge. We know that sulfur has a -2 charge, so we can cancel those charges so that we get Ca1S1, or just CaS. And it says solid once again, so make sure you include that little tiny S at the end. So this would be your answer here. One thing I do want to point out is when we have solids, we just have a singular thing. But let's say we were talking about a gas, like let's say we were saying oxygen gas is reacting with sulfur. When you have oxygen gas, you do not just do OG. Oxygen gas is one of our special elements that has a 2. So anything that can form a gas is always going to be in pairs of 2, and I'll go into that more in another video. So those are how you go from words to formulas and formulas to words. You will have a practice worksheet on that, so make sure you check that out. Again, generally most of these are going to be ionic, but you might have a couple that are molecular, so make sure your first step is always to identify, is this compound molecular or ionic, or covalent or ionic, and then go into that. Make sure you're identifying if something's a transition element and if you need to have that Roman numeral in there as well. Let me know if you have any questions on this. Good luck.